Lecture number 1. Today we will discuss about the real sequence and series. What is the sequence and what is the series? At first we will discuss about the sequence. In this sequence we will discuss on the topic. The first one is sequence, then bounded, unbounded, then convergence, then divergence, then infinite series, then geometric series, then limit, and the oscillates finite and oscillates infinite, then the Cauchy sequence at last. Okay, we will discuss. My suggestion to everyone, before coming in this lecture, you must go in my this portion, limit. Okay, and also there are many other lectures you must go, then you must come here. You must also check the definition of a function. We have also created a lecture for this topic, function. What is function actually? So what we have written here, a function whose domain, who is the domain, that is the domain. Okay, D-O-M-A-I-N, that is the domain, and that is the codomain, D-O-M-A-I-N. Okay, that is the function, that is the input. Actually this is input and that is output. Okay, so what is the meaning of input output? Suppose you have any function f of x is equal to x square. If you will put 1, then you will get 1, that is output. If you will put 2, then you are getting 2 the square is equal to 4, that is the output. If you are putting minus 2, then you are getting, suppose minus 2 whole square, that is 4, that is the output, that is the input. Okay, so input means we will put the value from this set, and output means whatever we are getting. Okay, that set is called the output. Output means codomain and input means domain. Okay, so now the function, a function whose domain is the set n of natural number. What is natural number? Natural number means 1, 2, 3 up to so on. That natural value is called the natural number. Okay, so natural number, it's started from 1 to infinite. Okay, so after then and range of the set of real numbers. What is range? That is the range. You can also say its name is also range. That is a range. And range of the set of real numbers. That must be real number, that must be natural number, this set. Okay, that is called the real sequence. That is the real sequence. It is denoted by S, that is the name of the function. N to R means if the input is the set of natural number and the output is the set of real number. It's the meaning. Okay, so after that we have denoted this symbol Sn, curly bracket. N is the natural number, or S1, S2 up to Sn. Example, the first example we have taken, Sn is equal to minus 1 to the power n. Now you can see that if you will put different values for n is equal to 1, then you are getting minus 1. If you are getting n is equal to 2, minus 1 square is equal to plus 1, that S2 is equal to 1. If you are minus 1 to the power 3, then this is again minus 1 up to so on infinite. Now the second example, suppose you have any other sequence, Sn is equal to 1 upon n, that is 1 upon n. Okay, so in this n belong to natural number. The first value, that is S1 is equal to 1 upon 1 is equal to 1. The second value 1 upon 2 is equal to 1 upon 2. Third value 1 upon 3 is equal to 1 upon 3 up to so on. Okay, now you can see that is the graph of this set and this set. Okay, this function you can say also, because we are just talking about the sequence. So Sn is equal to minus 1 to the power n. If you are putting different natural number, okay, then you are getting only two output, 1 and minus 1. But here if you are putting different value for n, then you are getting different output. So the first value is 1, then after 1 upon 2, 1 upon 3 up to so on 1 upon n. If you are increasing n tends to infinite, then in this condition 1 upon infinite, it is converging to 0. So that is the open interval. Okay, if you are converging this n to infinite, then this function is converging to 0. Its meaning, if Sn limit n tends to infinite, then this converging to 0. Okay, you must go in my this definition. What is the definition of limit? Already we have discussed. Okay, so means it is converging some other point L. Okay, so it means that there is a difference between Sn and L, that is any positive value. Okay, that is the definition of limit. You must go and then it will be clear. So similarly also, if you are increasing the value, if n is converging to infinite, then in this condition the whole thing it is converging to 0. Okay, so you can see also 1 upon infinite is equal to converging to 0. So that is the open interval. So this is semi-open semi-open interval or semi-closed interval. This is the closed interval or this is the open interval. Means this is converging to 0 and 1 is already there is a value. Okay. So now you have seen that we have taken two example number first and example number 2. In example number first, we have the range that is there are only two value. Okay. One output is 1 and second output is -1, and here you are getting different output. Okay, so this is there are only two value, so this is bounded. Okay, this is bounded, but you can say that also this there are also infinite value, but this is also bounded. That is also bounded. Bounded means this function, this 1 upon n. This is the greatest value is 1. Okay, this is less than 1, less than equal to, and this is less than equal to 0. Okay, so that is the bounded. Okay, this sequence it is bounded. This sequence also it is bounded. Okay, so bounded means you can find a smallest value and the greatest value in this function. Okay, so that is the meaning of bounded. What is the meaning of unbounded? Unbounded means, suppose you have any sequence Sn is equal to n. Okay, if you have this function, this sequence Sn is equal to n, if you are increasing n tends to infinite, in this condition this is Sn, it is also converging to infinite. Okay, in this condition you can see that this function is unbounded. Okay, this function is unbounded, S1 to infinite. Okay, in this condition you have this, you are getting this interval, means this is the range in this condition. This Sn is here. In this condition you will put a different value, then you will get 1, 2, 3, 4 up to so on infinite. So different output, it means that your range is 1 to infinite. Okay, so that is the unbounded, but this is the bounded. Okay, so that is the meaning of this convergence. Meaning, if you can see that in this function, if you are increasing this value, then after then this Sn is converging to 0. That is the meaning of convergence. Means your function it is going to somewhere in a finite value. And divergence means if you are just taking limit n tends to infinite and your Sn is also converging to plus infinite or minus infinite. Okay, so that means divergence. Divergence means if after taking a limit, if your function it is going to plus infinite or minus infinite, then you will say that this is the divergent. You can see that here Sn is equal to n. If n tends to infinite, then your function it is also going to infinite. So in this condition you will say that this function, that is the means sequence, that is the divergence. Okay, that is the meaning of infinite and this convergence and divergence. Okay, now what about the infinite series? Infinite series means if there are many infinite number of values. Okay, that is the infinite series. Okay, so now we will discuss about the geometric series. Okay, I will raise something, then after that I will discuss actually what is geometric. That is very important for you. So what is the meaning of geometric? Geometric means suppose you have such type of function 1, 2, 4, 4 to the 8, 8 to the 16 up to so on. Now divide this one, this and this, this and this, 2 upon 1, then you are getting 2. Now divide this and this, then you are getting 4 upon 2 is equal to 2. Now divide this and this, 8 upon 4 is equal to 4 to the 8, then divide this and this, 16 upon 8 is equal to 8 to the 16. So every time you can see that you have the, if you are dividing, this value and this value, then you are getting same value every time. So such type of series is called such type of sequence is called the geometric series, or series you can say also, that is also series. Okay, so if such type of series, then you will say that is the geometric series. So in geometric series, suppose there are infinite number of values. In this condition, how to find the nth term? Number first is how to find the nth term. You must note that for nth term, Tn is equal to the value is equal to, suppose you have such type of series 1, then after then you have 1 plus r square plus r cube up to so on r ki power n minus 1. Then the summation of all such type of series, that is the geometric series. In this condition, you will use Sn is equal to a into 1 minus r ki power n. A is 1, okay. Then after then 1 minus r, okay. That is the sum of all n term, okay, for geometric series. So if this n, it is converging to infinite, and r is less than 1, and it is converging to infinite, in this condition this will be 0. So you are getting in this condition Sn is equal to 1 upon 1 minus r, okay. This is for all n, okay. That is the sum of all points for infinite series, okay. So if in this condition, if you will say that r is equal to 1, if you will place r is equal to 1 here, then you can see that 0 upon 0, okay. So 0 upon 0 means undefined, undefined means divergence, okay. The first condition for such type of series, what is the summation? Sn is equal to sum of all points, okay. Sn is equal to 1 minus r to the power n upon 1 minus r. If we put 1 here, 1 minus 1 is equal to 0, 1 minus 1 is equal to 0, 0 upon 0 is equal to undefined. Undefined means divergence, okay. The meaning of this, that is not infinite, that is undefined. We don't know about this. What is this actually? That is meaning undefined, okay. So after then the second value, if you are putting r is greater than 1, if r is greater than 1, suppose r is greater than 1, okay, that is 2, 3, 4, any value. So in this condition, 2 to the power infinite means any value, big value, undefined value, very big value. Then this is also going to infinite any value, defined undefined value. So it implies also this is also divergence. 1 minus undefined upon 1 minus some value. So that is 1 minus undefined is equal to undefined, okay, that is divergence, okay. Now third condition, if r is less than 1, then you can say that this is the convergence. Convergence means you are your limit value n tends to infinite, your sequence Sn, it is converging to some finite value. That is the meaning of convergence, okay. Convergence means your sequence, it is converging to a finite value. Actually, what is the meaning of this? I will just explain you. Just I am erasing something. Okay, I will just explain here also. Suppose you have this function. Suppose you have this n plus 2 upon n. Okay. Suppose you have such type of any function. Okay. Suppose you have this. Sn is equal to n upon 2 upon n. Okay. N plus 2 upon n. If limit n tends to infinite, in this condition Sn is equal to limit n tends to infinite. So just put n common, then you are getting 1 plus 2 upon n, okay, and this n and n both will cancel because n is outside, both cancel. Then infinite, 1 upon infinite or 2 upon infinite, that is converging to 0. Then this value, it is converging to 1. So when n is converging to infinite, then your function, your sequence, it is going to a finite value. It means that this is the convergent. This is convergent. Okay. If it is going to any infinite value, means undefined value, then you will say that such type of series is called the sequence, or series is called the divergence. Okay. So Now we will discuss an important topic. I am just giving you one very important topic. Suppose you have any time summation of 1 upon n ki power p. Okay, and we will explain about this question. This is very important question. I am erasing something. What is the meaning of this? At first I will explain sigma 1 upon n. What is the meaning of this? This meaning 1, after then put second value, 1 upon 2, 1 upon 3, 1 upon 4, up to so on infinite. Okay, infinite means undefined value. Okay, so if we will add all points, you know that I don't know where the value, what will the sum of all such value. I don't know about this. But if I am putting 1 upon n to the power p, in this condition 1 plus 1 upon 2 to the power p plus 1 upon 3 to the power p plus 1 upon 4 to the power p up to so on infinite. And if p is greater than 1, in this condition you can see that is suppose let is p is equal to 2, let p is equal to 2. In this condition you have 1 plus 1 upon 2 ki power 2 plus 1 upon 3 ki power 2 plus 1 upon 4 ki power 2 up to so on this. Okay, so this is increasing rapidly. If the lower value, any lower value, it is greater than, it is increasing rapidly. In this condition the whole value it is converging to 0. You must note, whenever this lower value it is increasing rapidly, then the whole value it will be converged to 0 every time. Means example is, suppose you have this 1 1 2 3 4 5. In this condition this is converging to 0. If you will increase to 5 7 6 9 5 4 2, then you can see that is converging to 0. If you are increasing this lower part, then the overall that part it is converging to 0. You can see also 1 upon 100 is equal to 0.01. You can see if I am increasing again 1 1 2 3 4 5, in this condition 0.1 2 3 4 5. You have 5 1 2 3 4 5. Okay, so in place of this 1 and 1 2 3 4 5, 1 2 3 4 5. Okay, so you can see that is the very smallest value. Okay, so whenever you are increasing the lower part, then the overall value it is converging to 0. It is going to 0. This is close to 0. Okay, you can see that this is 0 and this value that is 0.01, but this value it is here. This value it is here. So it is, whenever you are increasing, then this is going to 0. Okay, this whole value it is going to 0 in this condition. So whenever the lower value it is increasing, the upper value means the whole value it is going to 0. Okay, so same thing also here. So whenever you are increasing the p, then the whole value it is converging to 0. In this condition the sum of the all value it will be means you are getting a finite value in this condition. So in this condition you are getting a finite value. It means that whenever your sequence it is going to a finite value, in this condition this series it will be converged. Converge means you are getting a finite value, and divergence means you are not getting a finite value. So this is the divergence. Okay, this is the divergence, but this is convergence. Every time you must note, whenever you have such type of any sequence, okay, in this condition, if p is greater than 1, then such type of function it will be convergence, otherwise it will be divergence. If you have p is equal to 1 or p is less than 1, then such type of series every time it will be divergence. Just let we will take example p is equal to -1. Let p is equal to -1 and keep -1, then you are getting summation of it will become n means put value 1 plus 2 plus 3 plus 4 plus up to so on infinite. You know that if you will add such type of value, then this value it is going to infinite. It means any undefined value. So such type of series is called the this is not a convergence series. Okay, means it is going to any undefined value. If p is less than 1 or p is equal to 1. So every time you must note for p is equal to 1 and p is less than 1, such type of series it is divergent. If p is greater than 1, then this is convergent. Okay. So we have also discussed about the infinite series, about the geometric series. Okay. About the limit, you must go in the limit chapter. Okay. Limit also already we have discussed. Now what about the oscillate finite and oscillate infinite? We will discuss. I am just erasing it. So before going to oscillate, I am just showing you some example. Let the first example an is equal to minus 1 to the power n. Already we have discussed. If you put n is equal to 1, then you are getting minus 1. If you are putting n is equal to 2, then you are getting 1. N is equal to 3, then minus 1. N is equal to 4, then 1, up to so on, such type of series. Okay, in this condition, you have only two value. Okay, minus 1 and 1. Okay. So you have only two value. Okay, this is the example number 1 about the sequence. Then the second example, suppose you have this an is equal to 1 plus minus 1 to the power 1 n. Then in this condition you have the first value. If you are putting n is equal to 1, then this is 1 minus 1 is equal to 0. If you are putting n is equal to 2, then this is 1 plus 1 is equal to 2. Okay, if n is equal to 3, then this is 1 minus 1 is equal to 0. Then 2 up to so on, such type of. So in this condition also you have only two value. Now the third example, suppose you have an is equal to n. Now you can see that if you place different value, then you are getting 1, 2, 3, 4 up to so on infinite. Okay, this is unbounded. Now another example 4. I am just taking an is equal to minus 1 to the power n into n. Now you can see that if you are putting different value, then you are getting, first you put 1, then you are getting 1. Okay, minus 1, sorry. Then after then you put 2, then you are getting 2. Then if you are putting 3, then you are getting minus 3. Okay, minus 3. If you are getting 4, then you are getting plus 4 up to so on infinite. So you have minus infinite and plus infinite, such type of limit point. Then after then this is also unbounded, that is also unbounded, this is bounded, this is bounded. Now the fifth, we are taking an is equal to minus 1 to the power n upon n square. So now in this condition you have 1 means minus 1. Okay, if you are putting 2 means 1 upon 4, 2 to the 4. 3, then you have negative minus, and 3 to the 9, 1 upon 9. Then if you are putting 4, 1, 2, 3, 4. If you are putting 4, then 1 upon 4, 4 is 16 up to so on such. Okay, you can see also there are infinite number of points, that is also unbounded. Okay, so but if you are increasing the value, if you are increasing, then the overall value it will be converged to 0. So at last you will get 0. Okay, so now sixth. Okay, sixth, suppose you have this an is equal to minus 1 to the power n, and you have 1 plus 1 upon n. Suppose you have this. Okay, in this condition you can see that if you are putting 1, then you are getting minus. Okay, minus 1 upon 1, 1 plus 1 is equal to 2. If you are putting n is equal to 2, then this is positive, and 1 plus 1 upon 2. 1 plus 1 upon 2 means 2 under 2 is 3 upon 2. Then after then if you are putting 3, then this is negative, and this is 1 upon 3. 1 plus 1 upon 3, 3 under 3 or 4 upon 3. Okay, such type of value you are getting. Okay, in this condition. So, and you can see that in this series, if you are increasing this value, then the limit point is 0. This is converging to 0. This is converging to 0. This is converging to infinite. This is converging to infinite. This is converging only such type of 0 and 2. Okay. And if you are increasing n, then after the infinite, 1 upon infinite, it is converging to 0. In this condition you are getting two value, minus 1 and 1. Okay. Actually that is the limit supremum and limit infimum. So we are just not, that is not in your syllabus. So now after then, suppose we have another example. Suppose we have such type of example, minus 2, 2, then after then suppose minus 3 upon 2, and suppose you have 3 upon 2, minus 4 upon 3, 4 upon 3, up to so on such type of function. In this condition, what will be the limit function? Okay, you can see that this is 3 upon 2, 3 upon 2, 4 upon 3, 4 upon 3, increasing, increasing, increasing. So this is 3 upon 2 means, minus 3 upon 2 means you are divide 3, 2 1 2. Okay, so 1 point something. Okay, if you are increasing this value, 4 upon 3, 4 upon 3, 5 upon 3, 6 upon 3, 7 upon 3. So in this condition you can see that its limit value, it will be go to minus 1 and 1. Okay, 3 upon 2, 4 upon 3, then this 3 upon 2, then 4 upon 3, then after then this 5 upon 4, 5 upon 4, then after then 6 upon 5. So both are increasing. So the if at the nth term, it will be goes to 1. Okay, you can also solve it. This is actually n plus 1 upon n. Okay, so you can take n common, then after then 1 plus 1 upon n, n cancel, limit n tends to infinite, 1 plus 1 upon n, infinite, 1 upon infinite, that is 0, it is converging to 1. So this value, it is converging to 1. Similarly, for negative, it will be converged to minus 1. So I have shown you many examples. Okay, what is sequence? I think that is clear. Okay, now at last we will discuss about the oscillates finite and oscillates infinite. Okay, I am just erasing it. So now the oscillate finitely. Now you can see that in this example you have 0, 2, 0, 2, 0, 2. So you are getting many different values. Then at first you got 0, then 2, then 0, then 2. So you are getting different values. So you can say that you have two value. So one time you are getting 0, then you are getting 2, then 0, then 2, then 0, then 2, then 0, then 2. You have seen the pendulum. One time it is coming here, then here, then here, then here, then here. You are putting different values. One time it is 0, 2, 0, 2, 0, 2, 0, 2. So that is oscillate. Okay. So that is oscillate finitely. So what is the oscillate infinite? Suppose I am taking one example, that is an is equal to, suppose you have m plus 1 upon n. Suppose you have this. So at first you have to fix this and run this value. 1 upon 1 upon 1, 1 upon 2, 1 upon 3, 1 upon 4, 1 upon 5, 1 upon 6. This is fixed. Let this value is any value. Then if you are increasing this, increasing, so this is fixed value. Okay, one time you have to fix this value, then after then increase this value. So in this condition you will get different values. Okay, suppose you fix this value 1, then after the 1 plus 1 upon n. If you are increasing n tends to infinite, then this value it will goes to 0. So you are getting 1, and after then you fix 2 value. Okay, in place of this, then 1 plus 1 upon n. If you are increasing this value, then it is converging to 0, but this value is fixed, so it is converging to 2. So one time you are getting 1, then you are getting 2, then you are getting 3. For this fixed value, you are getting different output. So such type of series is called the oscillate infinitely. Okay, you must discuss with some of your friends, then it will be clear. Okay, that is the oscillate finitely, that is the oscillate infinite. Okay, so at last we will discuss about what is the Cauchy sequence. I am just erasing it. So what is Cauchy sequence? In the Cauchy sequence, suppose you have any sequence and you are taking any two value n1 and n2. If for each two sub interval sn2 minus sm, mod is less than any positive value for all n1 n2 is greater than equal to 1. That is a positive value, any positive value. So in this condition, if the series it will be, if this is bounded, then you can say that this is the convergent. Actually the question is, whenever they have given you any question, how to find that the sequence is convergent or not. Okay, so he has discovered one theorem. By the help of this theorem you can find that this sequence is converging or not. Let you have this example, Sn is equal to 1 plus 1 upon 2 plus 1 upon 3 plus up to so on. Okay, plus 1 upon n. Actually this is sigma 1 upon n. Okay, why this is divergent? Okay, so now we will discuss. So you can see that you have Sn. Okay, Sn is equal to this. Let we are taking in place of n we are taking m, any value. In this condition, this we are putting m in place of n. Sm is equal to 1 plus 1 upon 2 plus 1 upon 3 up to so on plus 1 upon m. Okay, this is any value. Okay, what about Sm plus m? It means that we have 1 plus 1 upon 2 plus 1 upon 3 plus up to so on plus 1 upon m plus 1 upon m plus 1 plus 1 upon m plus 2 up to so on plus 1 upon m plus m. Okay, now we will subtract this two value, S2m minus Sm. Okay, we are subtracting. Then after then you can see that if we will subtract this to this, then this value it will be cut. Then you are getting this value. It means that you are getting 1 m plus 1 plus 1 upon m plus 2 plus 1 upon m plus 3 up to so on 1 upon 2m. M plus m is equal to 2m. Okay, so now you can see that this m is any variable. Okay, you can put any value. Now we can also write, if in place of 1 we are putting m, in place of 1 if you are putting m, it means that if you are increasing this value below value, I told you 1 upon 10 is equal to 0.1. Okay, 1 upon 100 is equal to 0.01. Okay, 1 upon 1000 is equal to 0.001. So what you are looking, if you are increasing the below value, then the overall value that is decreasing. So if you are increasing the below value, okay, we are increasing m plus m. Suppose we are writing m. In place of this also we are writing m plus m. Up to so on, we are writing everywhere m plus m. Okay, m plus m. Okay, if we are increasing the below value, then the overall value it will be decreased. Okay, in this condition, what will happen? If we are increasing the lower value, then the overall value that will be decreased. So this will be less than. Okay, very simple. If lower value increasing, then the overall value it will be decreased. Oh, you can see that this is 0.001. Before it was 1 upon 100. Before it was 1 upon 10. So if you are increasing this value, then this is decreasing. So it means that is less, that is also less. So if you are increasing this, then the overall value it is decreasing. So if you are increasing this lower value, then the overall value it will be less than this value. Okay, this value, overall this value. Okay, it means that S2m minus Sm, this is greater than. Okay, this value is this actually. So this value it is greater than this value. Okay, no problem. Now, so what we have written, you can see that we have, this is total number of m value. Because we started from here, you can see that m plus 1, m plus 2 up to m plus m. So these are the total of m value. It means that you will get m plus 2m. Okay, m plus m, everywhere m plus m, both cut. It means that is 1 upon 2. So now you can see that this value, this is not bounded. What we have written, it must be bounded. If you have any sequence and that is bounded with a positive number, then the series it will be convergent. But this is not bounded. So you can see that if the series is not bounded, so this is divergent. So why we write sigma 1 upon n, that is not convergent, that is divergent, because this is not bounded. Okay, this is very simple. Okay, so I have discussed everything. I think that you know. And suppose, okay, I am just erasing it. Okay, suppose someone has given you very simple question, and the simple question is this. I am just showing you a very simple question. Suppose someone given you this question, 3 plus 2 root n upon root n, where it is converging. Very simple. You will just take limit n tends to infinite, just take square root outside, then you are getting 3 upon square root n plus 2 upon square root n. Both cancel, infinite, 3 upon infinite is equal to 0, it is converging to 0, then it is converging to 2. So whenever someone has given you any sequence, and this sequence at n tends to infinite, this is going to a finite value, then this is the convergent. Okay, if you are getting infinite, then this will be divergent. To understand the sequence, you must, again I am just telling you, go to the limit. I have uploaded total number of 9 to 10 video for limit. You must go in the limit, L hospital rule, then your concept it will be clear. I try to just clear every topic. Okay, and I will also tell you something, some important theorem. Okay, the important theorem is, you must note, the first one is every convergent sequence is bounded. Whenever you have any sequence is convergent, convergence means this sequence that is bounded. Already we have discussed about the bounded. Okay, if you have any sequence and that is the sequence is convergent, it means that definitely it will be bounded. And second is every sequence converging to a limit point. Okay, and this is unique. Okay, this is unique, it means that this is unique too. So any sequence cannot converge to limit point. Okay, it will be converged